Okay, so one of the things you have to be able to do in chapter 10 is be able to plot points. So very basic stuff right now in terms of the beginnings of chapter 10. So remember, if you want to plot, and these are called ordered pairs. So if you look at this right here, let's say this is the point 2, 5. Now don't confuse that with an interval. That's not an interval. I'm not saying from 2 to 5. I'm saying I want to plot the point. This is a point, not an interval. So don't confuse that with interval notation. This is a point, and you represent a point using parentheses. And so I want to plot the point 2, 5. And so to plot the point 2, 5, you're going to start at the origin. Now the origin is where the x-axis and the y-axis intersect. So this point right here, see where it says 0? That's the origin. So the origin is where the x-axis and the y-axis intersect. So whenever you plot a point, you always start at the origin. And remember, we call this an ordered pair. Ordered pair. So when you do MyMathLab, those terms will be in there. All those terms, origin, ordered pair, point, x-axis, y-axis, and so on. In this ordered pair, the first number listed is called the x-coordinate. The second number listed is called the y-coordinate. And so one of the reasons why it would be called an ordered pair is because it's an alphabetical order. You have your x-axis, your x-coordinate, and then your y-axis, your y-coordinate. All right, so remember, we want to plot this point. So when it says to plot the point, it means to actually go in the coordinate plane and actually put a point there. So if you look at this plane, there are an infinite number of points. So there are an infinite number of points in this plane. I want to plot the point 2, 5. So there's only one point in this plane that represents this ordered pair. Now before we get to that, so notice that the x and y axis divide this plane into 4 quadrants. 4 quadrants. This is quadrant 1. And you go counterclockwise. This is quadrant 2. Quadrant 3. And this is quadrant 4. Right, so those are your 4 quadrants. So you need to know that terminology as well. Okay, so if I ask you, and some of you already know this, if not all of you, in what quadrant is the point 2, 5 located? Quadrant 1. All right, so to plot a point, if you didn't know this, make sure you listen carefully to what we're about to say. To plot a point, you start at the origin, and you start with the x-axis, and then you do the you start with the x-coordinate, and then do the y-coordinate. So when I'm at the origin, notice when I go to the right, those numbers are positive. When I go to the left, those numbers are negative. When I go up, those numbers are positive. When I go down, those numbers are negative. That's going to be important. So when I plot the point 2, 5, my x-coordinate is a positive 2, right? So that means that I'm going, since it's positive, I'm going to go to the right. And how many units are going to go to the right? 2. Now don't put the dot there. Don't put your little point there, because that's not the point 2, 5. You still have the y-coordinate to deal with. So I go to the right 2, and then since 5 is positive, I go where? Up 5. 1, 2, 3, 4, 5. So this is the point right here, 2, 5. Now it says label. If it says label, and usually it will, not always, but if it says label, what that means is where you put that point, denote what those coordinates are. So what are these coordinates? What goes first? 2 goes first, so x goes first, and then what goes second? 5. So that's the point 2, 5. All right, now if I want to plot the point, let's say you want to plot the point -3, -2. You want to plot that point -3, -2. Where do you start? At the origin. That's where you start, at the origin. Now, before we actually do the transformation, so to speak, what quadrant do you think this is located?
3.
Quadrant 3. All right. So at the origin, you start with the x-coordinate. The x-coordinate is a negative number. So I go which way?
Left.
To the left. How many units? 3. 1, 2, 3. See, it even says -3 right here. Then you do the y-coordinate. The y-coordinate is a -2, so I go where?
Down.
Down 2. 1, 2. So there's the point, -3, -2. So that's where that point's located. If I want to plot the point -5, 6, that's -5, 6. -5, 6. What quadrant is -5, 6 located?
Second.
The second quadrant. So where do you start?
Forward.
At the origin. Since x, you always do the x first. Since x is -5, I go which way?
Left.
5 units to the left, so there's -5 right here, right? But then I got to go to 6, so I got to go up 6. So 1, 2, 3, 4, 5, 6. All right, so that's the point, -5, 6. Okay? Now, what confuses people is if there's a coordinate of 0. So let's look at this. Suppose you want to plot the point 5, 0. 5, 0. Now, that's going to be important when we start talking about intercepts in a couple of sections. So we'll do intercepts next class period. So when we talk about intercepts, one of the coordinates will be 0, so you need to know how to plot those. You'd be surprised how many students get those intercepts confused. So I want to plot the point 5, 0. So where do I start?
At the origin.
At the origin. What is my x-coordinate?
5.
So I go which way?
Up.
To the right, 5. What is my y-coordinate?
You stay there.
My y-coordinate goes what?
0.
0. I stay there, right?
Yeah.
So this is a point 5, 0. That's a point 5, 0. Now, 5, 0 does not lie in a quadrant. It lies on an axis. So the directions is going to say which quadrant or axis does this point lie. You're going to say what?
Y-axis.
Not the y-axis, the x-axis. The x-axis. So notice that if you're on the x-axis, what is the y-coordinate?
0.
0. No matter where you are on the y-axis, on the x-axis, my y-coordinate is 0. So for example, if you want to plot the point -8, 0, since my y-coordinate is 0, where should that point be?
-8 is
But which axis though?
Oh, on the X.
X-axis. So if I plot the point -8, 0, you'll notice that it is on the x-axis. And when we start talking about intercepts, we'll come back to that idea. No matter where we are on the x-axis, my y-coordinate is always what?
On the Y-axis.
No matter where we are on the x-axis, my y-coordinate is always what number? 0. So -8, 0 is here. So remember, you go to the left 8. Since y is 0, you stay there, right? So that's the point -8, 0. So if I want to plot the point 0, 10, 0, 10, this time which coordinate is 0?
Y.
No.
Wait, asking.
Which coordinate is 0 this time? No. The x-coordinate.
Coordinate is 0.
The x-coordinate is 0, right?
So you just move up the Y-axis.
Yeah, I was like, what is she talking about?
You said, where's the 0?
No. Well, I did say that because you didn't. So what I wanted to say, where's the 0? I wanted to say, what's the x-coordinate? All right. But yeah, you do see a 0 in the middle. I understand that. There's a 0 in the middle of this thing. But that 0, 0 right here is called the origin. All right. So which coordinate is 0 this time? The x. All right, so let's see where that point's going to be located. You start at the origin. Since x is 0, do I go right, left, or stay?
Stay.
I stay. My y coordinate is a positive 10, so do I go up, down, or stay? I go up 10. So there's the point 0, 10. So when the x coordinate is 0, where's the point located? On the y-axis. That's going to be important when we talk about intercepts. That's going to be important. Where is the point 0, 0 located? At the origin. There's the point 0, 0 right here. You're what?
You got nervous with your look.
I saw that, yeah. That's the point 0, 0 at the origin. So 0, 0 is the origin. That's the origin. Okay? All right, so that's a quick review of plotting points. So a point will lie either in a quadrant or an axis, or on an axis. Okay? Now, what you're going to do is this. So if you recall, yep, Tuesday, April 9th. Okay, so everything we've done to this point has either been an equation or an inequality, right? Okay, and if you look at all those equations, test 1, test 2, or the inequalities from test 2, how many variables were in those equations or those inequalities? Just 1. All right, now what's going to happen is that we're in chapter 10, we're going to look at equations in 2 variables. So it's no longer 1 variable, it's going to be 2 variables now. So up until this point, you've dealt with equations in 1 variable, x plus 5 equals 7. Now you're dealing with equations in 2 variables, 2 different variables, and they're going to be the variables x and y. And the variables x and y are going to correspond to this coordinate plane. So notice you see the variable x, the x-axis, and you see y, the y-axis. So they're going to correspond to this. So here are equations in 2 variables. So you have, and I'm going to kind of put them in 2 columns here. So those are examples of equations in 2 variables. In the first column, go ahead and write something like y equals 3x minus 1. So notice you do see that's an equation in 2 variables. Your variables are what? X and y. It's not 1 variable, it's 2 variables. 2x minus 3y equals 6. There's another equation in 2 variables. 3x equals 2y plus 1. That's an equation in 2 variables. In the other column, let's write this one. Y equals 3x squared minus 1. That's an equation in 2 variables as well. You have the variables y and x. But notice this time, what's the exponent of the x? 2. Y equals 3 divided by x. That's an equation in 2 variables. Okay? Y equals the square root of x. That's an equation in 2 variables. Okay, now, in this course, we're only interested in,
The first side, the first one.
the first, you talk first side, you mean this? Yes, we're only interested in this kind. In the next course, you'll be interested in this kind, and this kind, and in college algebra, you'll be interested in this kind. So this right here, in this course, you're only interested in linear equations. So these are linear equations, the first three, the first column. Those are linear equations. So basically when I graph them, noticing the word linear is the word line. So when you graph these, you're going to end up with a line. So you graph a linear equation, the graph of a linear equation is a line. Okay, so the graph of a linear equation is a line. All right, now what makes them linear, for us right now, just remember this way. What makes them linear is that the exponent of both the x and the y, the exponent of both x and y are ones. So notice y to the first, x to the first, x to the first, y to the first, x to the first, y to the first. And the variables don't appear in the denominators at all. Okay? All right. So here, this is not linear. Why would this be not linear based on what we just said? Because the exponent of x is not a 1, the exponent of x is a 2. You're going to learn in the next course that this is called a quadratic equation. And the graph is a parabola. Looks like this. Right. So you may remember that from another course. The third one here, that's not x to the first. You're going to learn, even in this course, you're going to learn that this is really x to the, actually this is the next course, sorry. In the next course, you're going to learn that this is x to the 1/2. So the square root of x, you're going to learn in the next course, Math 99, that that's really x to the 1/2 power. So why would that not be linear? Because the exponent of x is not a 1, the exponent of x is a what? 1/2. This is called a square root function, or a square root equation. And the graph is not a line. The graph looks like this. It looks like half of a parabola. See how it looks? So if I turned it sideways like this, it would be like part of a parabola. Right. So the graph of a square root is not a line. So those two you're going to deal with the next course. Now this one here would be college algebra. This is called in terms of the graph. Now next semester you're going to talk about this kind of equation, but you're not going to graph them. This right here. You're going to graph this in college algebra. This is called a rational equation. So it's called the rational equation. And you may say, well, x 3 divided by x does have an exponent of 1, but where's that variable located? In the denominator. It cannot be located in the denominator. Okay? All right, but that's, so these are linear. This would not be linear. This is rational. You're going to see that the graph of this one will look something like this. And that's in college algebra. You don't have to know what it looks like now. But it'll look something like this. So that's that graph. Okay? All right. So when you get to college algebra, you'll be graphing things like this. All right? So these are linear. These are not linear. Okay, now let's start talking about graphing linear equations. So let's look at this linear equation. All right, so y plus x equal 5. Now, one of the things you have to do in my math lab and also on the worksheet is this idea. They're going to give you a t-table. They're going to give you a t-table. And when you graph these, for the most part, you're going to use t-tables when you graph them. You use t-tables. So the t-table is going to look like this. So look like a T. And then remember you're going to be plotting points, and these points are ordered pairs. In the ordered pair, which coordinate is listed first?
Y.
No, X.
X.
So you already forgot that. Make sure you know that. X is listed first. No, I did not. I said in an ordered pair, what coordinate is listed first?
The X, of course.
Yeah, you gotta listen. And then the Y coordinate is listed second. So make sure when you do the ordered pair, X is first and Y is second.
You said in an ordered pair, what is
X is listed first, Y is listed second.
But how did you X it? Because I'm gonna write it the way you X.
I don't remember. In an ordered pair, which coordinate is listed first?
Okay.
Okay. Okay. So let's suppose that, and it's going to look like this for the when you start working on this section of my math lab. Let's say this is 2 right here. This is -4, and let's say this is 0. Okay. All right. So you're going to be given some coordinates for either an X or a Y. That's how it's going to start out. And so, for example, in the first one, they're telling you that they want you to use what number for X? 2, and then you have to find what? Y. Well, all it is just plug and chug. Plug and chug. You go back to your equation, wherever you see the variable X, what do you plug in? 2. And then you use your knowledge from the first 2 tests. Okay? So for this one, I'm going to say, well, if X is 2, then that's going to be Y plus what? 2 equal 5. And then you solve for Y using your knowledge from the first test and the second test. How to get Y by itself? Subtract 2 from both sides, and now you found your Y coordinate. What's my Y coordinate? 3. So my Y coordinate is 3. Now that happens to be a solution. These are called solutions to this equation, because when I plug in 2 for X and 3 for Y, that equation is a true statement. So look, Y is 3, X is 2, right? What's 2 plus 3? 5. So that's a solution. Remember, a solution are numbers. In this case, it would be a point, since we're dealing with 2 variables. In this case, it's a point that makes the equation a true statement. Now let's do the other one, the next point. What is Y this time? -4. So in the equation, where we see the variable Y, what do I plug in? -4. So for that one, I'm going to get -4 plus X equal 5. And then you use what you've learned before. How to get the variable X by itself now. Add 4 to both sides. And now I found my X coordinate. What's my X coordinate? 9. So I found another solution to this equation. Because when I plug in 9 for X and -4 for Y, what's 9 plus a -4? 5. So that's a solution. Then let's look at the other point. This time, what is X? Oh, I'm going to circle what was already given. So 2 is given here, -4 was given here, okay? And then 0 is given here. So this time, what is X? 0. So I get Y plus 0 equal 5. Well, what's Y plus 0? What's Y plus 0? Y. So what does Y equal? 5. So there's another solution of that equation. In fact, how many solutions are there? An infinite number. There's an infinite number of solutions. I've only listed how many of them? 3. I could have put decimals in there if I wanted to. I could have put fractions in there if I wanted to. But it's always easier to use integers. Because if you use decimals, you're going to have to approximate where these things are in here. All right. Now remember, those are solutions, right? Okay. So let's plot those 3 points. Where's the point 2, 3 located?
On the first quadrant.
Very good. I'm glad you said quadrant 1. Yeah, same thing. It is the same thing. So to plot the point 2, 3, you start at the origin, go to the to the right 2, and then what? Up 3. Now, it's going to say label. So if it says label, that means you don't just put the little dot here. You got to say what? 2, 3. All right, it's easy to forget to do that. So don't lose any points just because you didn't read the directions carefully. Then where's the point 9, -4 located? In what quadrant? Quadrant 2. So, not quadrant 2. What's quadrant 9, -4 is in what quadrant? Quadrant 4. So 9, -4 is right here, right? 9, -4 right here. And then the point 0.05 is located where? On the y-axis. 0.5, since, you remember, sorry, the origin, since x is 0, you stay there. Since y is +5, you go up 5. Now, if I were to plot more points, what pattern do you see?
Diagonal.
Okay, so she's saying this, that if I were to plot more points, and if I were to take a ruler, they would all lie along the edge of that ruler, right? So I'm going to ask you this. Is this point right here that I'm putting a dot on, would that be considered a solution?
Yes.
Yes. Would this point right here be considered a solution?
Yes.
Yes. In fact, we said a while ago that there are how many solutions? An infinite number. So when you're asked to graph this line, and that can be the directions to graph, you're graphing its solutions. You're graphing its solutions. Now, when you graph a line, don't just do this. You have to do the arrows. If you forget the arrow, you're going to be very disappointed in me. And not disappointed, but upset. Because you're not get full credit. All right, you got to draw your arrows because the arrows indicate that it keeps going. If you didn't draw an arrow there, it would indicate a segment. Remember, a segment has endpoints. A line has arrows on both ends. All right. So this right here is the line y plus x equal, what was it, 3? 5? That's the line y plus x equal 5.
You said we're gonna need a ruler.
It's best, I mean, I'll have rulers for you in the test, but when doing your worksheet, if you can use a straight edge, maybe your ID or something, because the graphs are not that big on the worksheets. They're a little bit smaller. All right, so remember, when graphing a line, when graphing linear equations, the graphs are lines. All right, so remember, your solutions are any point that's on this line. So I'm going to ask you this. Is this point right here, so I'm going to ask you this, I'm going to write it down here. Is the ordered pair, the ordered pair, -6, 3, a solution of y plus x equal 5? Well, so right away you said no because you saw that -6, 3 is located here, right?
Mm-hmm.
It can't be a solution because it's not located where?
On the line.
On the line. So yes, the answer is no for that reason. The other reason is you could plug in, for x you could plug in what? -6, and for y you could plug in 3, and you'll notice that the left side is not going to equal what? 5. So watch. 3 plus a -6, what does that equal?
-3.
-3, and that is not equal to 5. Okay? So any point that's located other than on the line is not a solution. So there's an infinite number of points in this plane, there's an infinite number of points on this line, but the solutions are only the ones that are on this line. And there are how many solutions? An infinite number. You can't list them, so you graph it instead. Okay? All right, so that's the idea of graphing lines, the idea of solutions, ordered pairs. Okay? All right, now, the easiest kind of linear equation to graph, is when y is already by itself. That's the easiest kind. So for example, So notice that in this equation, and what kind of equation is this? Linear. So in this course, it's not difficult to determine what kind of equations you have. It's the next course and the course after that, especially in college algebra, because you're going to have all kinds of equations. In here, it's either linear. I mean, they're all linear. In the next course, it'll be linear, it'll be quadratic, it'll be square root, it'll be absolute value. So you only deal with 4 next semester. In the next course, you deal with a lot more. So when I ask what kind of equation is this, then you only have one kind that we've talked about. It's what? Linear. And when you graph a linear equation in 2 variables, it's a what? A line. All right, so let's go ahead and graph this. Now notice y is by itself. Remember, the easiest kind is when y is always by itself. Y won't always be by itself, but when it is, it's the easier kind to graph. Notice, though, the coefficient of x is a fraction. So when you're plotting points, see how easy it was to plot these points here? Because there was no hesitation in terms of plotting these points, because these coordinates were what kind of numbers? No, -4 is not a whole number. I wanted you to say what word? Integers. Whole numbers are 0, 1, 2, 3, 4. Okay, the fact that -4 is negative, that this number here is negative, does not make it a whole number, makes it an integer. So these are all integers. All right, so they're integers. So when you have a linear equation and the coefficient of x is a fraction, when you do your t-table, it is easier to choose numbers for x, that are divisible by this denominator. Okay? Because if you did not, let's say you chose the number 8. Let's say you chose 8. I want to show you what's going to happen if I choose 8 for x, if I let x be 8. Then I'm going to have to figure out what this is. Y equals 2/3 times 8 minus 5, right? Okay, so then I'm going to have to say, all right, 8 is 8 over 1. Then I'm going to have to figure out what 2/3 times 8 is. 2/3 times 8 is 16 divided by 3. Then whatever that is, I'm going to have to subtract 5. Then if I don't have a calculator, I'm going to have to find the LCD, do it by hand. And so what's the LCD? No. 3 and 1. 3. The LCD is 3. And so you write equivalent fractions now. Since these numbers are the same, that means the numerators have to be what? The same. Now to go from a 1 to a 3, I need to multiply this by 3. I got to multiply this by 3, and so this is a what? 15. So when x is 8, what is my y coordinate? 16/3 minus 15/3. 1/3. So then you got to figure out, all right, now I've got to go and plot that point, 8 1/3. So then you got to go in the coordinate plane, you got to say, all right, I'm going to go 8 units to the right, and then I'm going to have to go 1/3 unit up. So then you're going to be estimating now. Okay, so 8 1/3 is about here. That's what you have to think about. So the point's this. You see how you could have easily made a mistake anywhere in this process. So when you have a coefficient that is not a whole number or an integer, in this case it's a fraction, choose numbers for x that are divisible by 3. So I'm going to ask you, give me a number of x that's divisible by 3. 6. What's another smaller one? 3. Even 0, right? 0. So I could have chosen 0. I could have chosen 3, because 3 goes into 3. 3 goes into 0 evenly. I could have chosen -3 if I wanted to. I could have chosen 6, because 3 goes into 6. 3 goes into -6, doesn't it? What are some others?
12.
Let's do the next one above that one. 9. -9, and so on, right? Okay. So there's an infinite number of these nice numbers I can use. So if this was a 2/7, then what numbers would you want to use besides 0? 7, -7, 14, -14. Very good. All right, so you get the idea. So since I'm using these numbers for x, it's going to turn out that my y coordinate is going to be integers as well. They're not going to be any fractions. Now, to graph a line, you just need 2 points. But we're going to use 3. Because if you mess up on one of them and you use 3, they should all lie in the same line, right? So if you mess up on one of them, then you know that somewhere you messed up. You got to go back and figure out where you messed up because all 3 points have to lie on the same line. So if you only do 2 and one of them is messed up, then your line's going to be wrong. Use the third one to check as a check. So always use 3 points just in case you mess up with something. All right. 0 is always the easiest to use. When y is by itself, 0 is always the easiest to use for x. So what's what happens when x is 0? I get y equals 2/3 times 0 minus 5, right? What is 2/3 times 0? Good. What's 0 subtract 5? So when x is 0, what's my y coordinate? -5. Let's do 3. Y equals 2/3 times 3 minus 5. 2/3 and 3 minus 5. And you see this 2/3 times 3 right here? Remember, the whole purpose of using numbers divisible by 3 is so this denominator can reduce in the number I chose for x. 3 goes into 3 one time, 3 goes into 3. So what is this product that I have circled? 2. What is 2 subtract 5? Nope. Not 3. -3. -3. Okay. Now you see, you would have put 3 there.
My line would have been wrong.
You're right. The points would not have lied on the same line. Okay. So you would have realized at that point I did something wrong. Okay. Now let's do -3. Y equals 2/3 times a -3 subtract 5, right? Okay. Remember the whole point of multiplying, of using numbers for x that are divisible by this denominator so that this denominator will become a 1. 3 to 3 is 1. 3 to -3 is a -1. So what is this product right here that I have circled? And what is a -2 and a -5? -7. So remember, to graph a line, you know how many points? 2, but we're going to use how many? 3. So if the direction says make sure you use 3 points and you use 2, you're going to be upset because you won't get full credit, okay? All right, so I'm going to plot those 3 points, 0, -5, 3, -3, and -3, -7. Where is 0, -5 located?
In the first quadrant?
No. When one of the coordinates is 0, it does not lie in a quadrant. It lies on an axis. Okay? I'm going to ask you again. Where is the ordered pair 0, -5 located?
X-axis.
The y-axis.
0, -5? Oh, because you go down.
You go down.
Yeah.
Okay. All right. So 0, -5 is located here. This is 0, -5. So it's on the y-axis. Remember, we had a discussion a while ago that said that no matter where you are on the y-axis, your x-coordinate is going to be what? 0. That's going to be important when we talk about intercepts soon. And no matter where you are on the x-axis, which coordinate is 0? Do you remember? If I ask you what are the coordinates at this point here, what are you going to say? 5, 0. So no matter where you're on the x-axis, which coordinate is 0? I'm going to ask you again, what is this point right here? 5, 0. So I'm going to ask you again, no matter where you're on the x-axis, which coordinate is 0? Y. You said 5, 0. Why 0? Okay? That's going to be important when we talk about graphing lines using intercepts. Okay, so there's this point. The next one is 3, -3. What quadrant is 3, -3 located? Fourth. So you go to the right 3, down 3, right? So this is the point 3, -3. And then finally, the point -3, -7. What quadrant is that? -3, -7. The third quadrant. So you go to the right, you start the origin, you go to the left 3, and then down 7. So it's in the third quadrant. So if I did this correctly, all those points should be collinear. I'm using the word collinear. Are they collinear? I think there are 2 L's in collinear. Collinear. All right, I could be wrong. 1 L or 2 L's. All right, and then you now mistake that people make is that when I say graph this line, they'll do the 3 points and then they'll stop. Well, if you don't do anything else, you're indicating that this line only has how many solutions? 3. How many solutions does a line have? An infinite number. So what is it you got to draw? A line, though, right? All right, so you draw a line. And so there's your graph. So this is the graph of y equals 2/3 x minus 3. Oh, was it minus 3? No, minus 5. Okay?
So from our previous line, the intersecting point is 6, -1.
What do you mean by the intersecting point?
Like, because I did both of my lines on the same paper. From the last problem and then this problem.
Okay, they're distinct problems. What do
I
you?
know, but
Oh.
I was just saying the intersecting.
Oh, okay. All right. Well, that's a good point because in college algebra, you got to graph systems. In college algebra, you have to solve systems, and a system is where you put 2 lines together. So one of the things you're going to do is to solve a system. One way is to graph them, and that's what you're going to do. You're going to graph the 2 lines, and wherever they intersect is a solution. So there you go. So you can do that in college algebra. So you can graph systems. That would be called a system, where you look to see where they intersect. That would be called a system. So remember that when you get to college algebra.
I will forget.
Yes, you will, but it's okay. All right, now let's look at this one. So let's look at this line.
This is fun, I like this.
What?
I like graphing lines, it's fun.
No, it's not difficult. It's fairly easy to deal with. Okay, so let's look at this one. Suppose we had y equals -3x plus 4. Y equals -3x plus 4. Again, y is by itself, so that's the easy kind. When y is by itself.
-3x?
Yeah. So when y is by itself and use a t-table, you want to plug in numbers for x. Y is by itself, you plug in numbers for x. You solve for y. Since the coefficient of x is an integer, it doesn't matter what numbers I choose for x. It's not a fraction. If it was a fraction, I'd be a little bit more specific as to what I would choose for x. But it's just an integer. So I can pick any number for x. If I pick any number for x, except when I say pick any numbers for x, I mean make your x's integers. Don't choose decimals or anything like that. You can, but then you have to approximate where they are. So give me a nice integer I can use for x.
7.
Huh?
7.
Okay, now let me say this. If you're going to, remember, technically you can choose 7, but you want to make sure that ordered pair you get lies in the plane that you have. So if you look at your graph, it only goes up to 10, -10, +10, -10, right?
Yeah.
So if I choose 7, what's -3 times 7? -21 plus 4 is way beyond -10. So it won't lie in that plane. So choose numbers that will make these points lie in the coordinate plane that you're given.
2.
Yes, but I was hoping someone would say 0.
Oh.
0 is always the easiest one to use. So if x is 0,
If we have a choice, always choose 0.
yes. In fact, when we get to the graphing by intercepts, 0 is going to be one of them. So y equals negative 3 times 0 plus 4. So what's my y coordinate? Taking a long time to say 4. All right, so I would plot the point 0, 4. Give me another number for x. Someone said 2, right? So if x is 2, I get y equals negative 3 times 2 plus 4. What's negative 3 times 2? And what's negative 6 plus 4? Negative 2. And then I need one more. Let's do a negative number for x.
Negative 2.
Negative 2. If x is negative 2, I get y equals negative 3 times a negative 2 plus 4. What's a negative 3 times a negative 2? Positive 6. Positive 6 plus 4 is 10. And so you plot those points and you draw your line. So they should lie in the same plane. I mean on the same line, excuse me. You see the x and y coordinates are all integers, so that makes it easier to deal with. So 0, 4 is on the y-axis. Now remember, it's going to say label. So if it says label, putting the dot there is not what that means. What does it mean to label? You put the coordinates. And remember, the coordinates are denoted in parentheses.
Didn't you also say that was plotting? Or is plotting where you-
No, the plotting is just putting a dot there.
Okay.
All right, 2, negative 2 is in the fourth quadrant, so that's here. And then negative 2, positive 10 is in the second quadrant, so that's here. And then you use your ruler to graph this. Do something like this. Now, it didn't exactly go through this point, but it's fine. So there's your graph. Make sure you go through the 3 points and you draw arrows, okay? Extend it and draw your arrows. And so there's the line, y equals negative 3x plus 4. Now, okay, let's look at this one. So, let's graph y minus 3x equal 2. Y minus 3x equal 2. Okay, remember a while ago I said this. I said that the graphs are easier to graph, the linear equation is easier to graph if the y is by itself or if the variable is by itself. All right, so if I wanted to, see how the coefficient of y is 1 here? So if I wanted to, I could get y by itself, which means I got to get rid of this subtract 3x. So what do you do? Add 3x. And so then I'm going to write this as y equals, and always put the variable x first. So it'll be 3x plus 2. So you see how I went from that to getting y by itself. So y equals 3x plus 2. So it's very helpful sometimes. It's very helpful sometimes if you can get the variable by itself. Okay? All right. So y minus 3x equal 2 means the same thing as y equals 3x plus 2. And then now use the t-table. So give me a number for x.
0.
0. So if x is 0, I get y equals 3 times 0 plus 2, which is what? 2. Give me another number for x. I was saying, give me another number for x.
2.
2. Y equals 3 times 2 plus 6. Oops. Plus 2. So that's 6 plus 2, which is 8. Give me another number for x. I'm not going to use 4 because that's going to be 14. Let's use a negative one. Negative 2. So if x is negative 2, I get y equals 3 times negative 2 plus 2. So that's negative 6 plus 2, which is a negative 4. All right. So then you plot those 3 points and then draw your line. Plot those 3 points and then draw your line. So this is going to be y minus 3x equal 2. And so 0, 2 is located here. 2, 8 is here. So that's in the first quadrant, 2, 8. And then negative 2, negative 4 is in the third quadrant, so that's here. And remember, they have to be collinear. So you make sure they lie in the same line. Now remember, when you graph a line, you graph in the solutions. And there are an infinite number of solutions. You're going to use those 3 you just found to help you graph the others. Okay? All right, now, let's suppose we had this that we wanted to graph. Suppose you want to graph this. Okay, x equals negative 3/4 y plus 2. This time, what variable is by itself? X, okay? No big deal. Remember, the easy kind of equations is when one of the variables is already by itself. So x is already by itself, so I'm going to use a t-table. Except now listen, before when y is by itself, I plug in numbers for x. Since x is by itself, I'm plugging numbers for y. Okay. What's the easiest number to use for y?
0.
0. So notice I'm plugging to y first. So if y is 0, I get x equal negative 3/4 times 0 plus 2. What's 3/4 times 0?
0.
What's 0 plus 2?
2.
So there's my x coordinate. So when x is 2, y is what?
0.
0. Now remember, the coefficient of y is a fraction, so I'm going to choose numbers for x that are divisible by, which is 4. So I already chose 0 for y. Now give me another number for y then. No. No, be careful. 4 does not go into 2 evenly.
8.
8. But what's the other one? That's another nice one. 4. And then negative 4, right? So let's just use those. But you could have chosen 8, negative 8. What are some other numbers? 16, negative 16, 12, negative 12, and so on, right? Okay. If y is 4 this time, I get x equal negative 3/4 times 4 plus 2. The 4's divide out. What's this product right here? When what's negative 3 plus 2? Negative 1. So that ordered pair is negative 1, 4. When y is negative 4, I get x equal negative 3/4 times a negative 4 plus 2. 4 to 4 is 1. 4 to negative 4 is negative 1. What's this product right here? Positive 3. 3 plus 2 is 5. So then I plot the point 5, negative 4. And so you put that on the coordinate plane. You plot those 3 points, and they all should lie in the same line. They should be collinear. So when I do this, so 2, 0 is located where? 2, 0.
X-axis.
the x-axis. So you go to the right 2 and you stay. Negative 1, 4 is in the second quadrant. And then 5, negative 4 is in the fourth quadrant. And notice they do lie in the same line. They are collinear. So I did not make an error.
Don't forget your arrows.
Yep. And we're using a voodoo doll on me. All right. So there's your line. X equal negative 3/4 y plus 2. All right. Okay, now let's look at this one. Okay, suppose I had this. Suppose I had, I want you to graph x minus y equal, let's say, a negative 3. X minus y equals a negative 3. Okay? Yeah, so remember, the easiest kind of linear equations to graph is if you can get the variable by itself. All right, because if the coefficient turns out to be a fraction, you want to use nice numbers. So if you look at this, the coefficient of x here is what? 1. The coefficient of y here is what? Negative 1. If one of the variables has a coefficient of 1, that's the one you want to get by itself. See, this is a coefficient of 1. This is not a coefficient of 1. That's a coefficient of what? Negative 1. All right, so it is easier in this case to get x by itself. See, if you get y by itself, you would have to subtract x, but you didn't get y by itself, you got what by itself? Negative y. Then you have to divide by what? Negative 1. I'll show you both ways, but that's going to be the idea. So get x by itself, because that already has a coefficient of what? 1. So you're going to add y to both sides. That's a y. So I get x equal what? Put the variable first. Y minus 3. So x equals y minus 3. And then you find your 3 points. Since x is by itself, you're going to plug in numbers for what? Y. What are some easy numbers to use? 0. Give me another. 2 more. 1. Give me another one. 2. Okay. So if y is 0, x will be 0 subtract 3, which is what? What is it? Oh my Lord, guys, come on now. What's 0 subtract 3? Negative 3. If x is 1, I'm sorry, if y is 1, I get x equal 1 minus 3, which is what? Negative 2. You can do that, but you can't do 0 subtract 3, huh? If y is 2, I get x equal 2 subtract 3, which is negative 1. All right, you plot those points, and they should all lie on the same line. What?
I was thinking there's a lot of negatives on that one.
Yep.
Is it because we used so little,
Yeah, if I would have chosen, let's say, 6 for y, I would have gotten 6 subtract 3, which would have been a positive. Yeah. It always depends on the numbers you choose. So x minus y equal negative 3. So negative 3, 0 is on the x-axis. That's negative 3, 0. Negative 2, 1 is here. And negative 1, positive 2 is here. And notice you get this, right? Okay. All right, now, Let's look at this one. Oh, I wanted to show you a while ago that this one here. Let me go back to this one. Remember, I said it would have been a lot easier to get x by itself. Suppose someone said, "Well, I want to get y by itself." Now, that's really important because in another section, whenever you get y by itself, that's called slope-intercept form. You don't know that now. You will next week. Slope-intercept form. Slope-intercept form is where you get y by itself. So at some point, you are going to have to get y by itself here. So if it says write in slope-intercept form, that means get what by itself? Y. So let's see how to get y by itself. So there's several things you can do. You can bring the variable x to the other side. I'm going to go ahead and rewrite this over. All right. And so I would have to subtract x, right? Because x subtract x is 0. But what's left? Nope. Negative y, or negative 1y, right? Equal, and this would be negative x subtract 3. Okay? But then you got to get y by itself, which means you have to divide both sides by negative 1. That's what you would have to do. And then negative 1 divided by negative 1 is a 1, positive 1. 1 times y is y. But then you get this right here. But you got to remember that this expression right here is really this. A negative x divided by negative 1 is a what? Positive x. A negative 3 divided by negative 1 is a positive 3. So x minus y equal negative 3 is the same thing as saying x equal y minus 3, or y equals what? X plus 3. So it did not matter whether you got x by itself or y by itself, but notice how difficult it was to get y by itself since it was negative, since it had a negative coefficient. But in one of the sections coming up, you are going to have to learn how to do that.
So what is it called when we get x by itself?
It's not called anything. The reason why the other one's so important, the getting y by itself is so important, because you can, when you get y by itself, you can determine the slope right away. And you can determine the y-intercept, which is another section. So if I plot some points here, I want to show you this. Watch. If I let, I'm just going to use the same points here. If I let x equal negative 3, I get y equals negative 3 plus 3, which is what? 0. Which is this right here, right? If I let x equal negative 2, I get y equals negative 2 plus 3, which is what? 1, which is this right here. If I let x be negative 1, I get y equals negative 1 plus 3, which is what? 2, which is this right here. All right, so you see those are the same equation, just written differently. But for right now, the easiest, if you had this, then obviously it's easier to get the variable x by itself. But in another section, when you're asked to get y by itself, and you will, notice what you have to go through. And we're going to go through this process again.
What is it called again?
Slope-intercept form. Slope-intercept form. And that's y equals mx plus b. So you're going to see this in a couple of sections. Okay, a couple of sections later. All right. Now, look at this. Okay, listen carefully about this. So all of these right here were equations in how many variables?
3.
Not 3 variables, 2, x and y. Now, when this isn't college algebra, what it used to be in college algebra, you would have equations in 3 variables, x, y, and z. That's that 3 dimension. But they don't do that anymore in college algebra. In college algebra, they don't cover it. You are going to use it in calculus, but not in college algebra. All right. Now, don't make this difficult. Y equals 2. That's an equation. That's a linear equation. This is a linear equation. It's only one variable, true, but it's still a linear equation, and I can consider this to be a linear equation in two variables. I can write this linear equation in two variables. Okay, so you're on the right track with that idea of 0, but y'all agree that what I'm about to write is this: 0 times x plus y equal 2. So see, the variable x is missing, right?
Yeah.
So the variable x is missing. That means the coefficient of x is what? 0, because 0 times x is 0, and 0 plus y is y. So this is still considered a linear equation in how many variables? 2. Okay, now here's how you want to deal with this in terms of graphing. Whenever you only have one variable, like this would also be considered a linear equation in two variables, because this time what's the coefficient of y? 0. So this would be x plus 0y equals 2. So whenever you have a linear equation in two variables and one of the variables is not there, then you're dealing with either a horizontal line or a vertical line. Notice in all the graphs we've done, were any of those horizontal or vertical? No, they were slanted, right? They either rose or they fell. They either rose or they fell. So this graph falls, this graph rises. So as you go from left to right, you see it's rising, right? This one's falling as you go from left to right. And the reason it'll rise or fall here is because you really have two variables, x and y. And none of the coefficients are 0. Whereas here, the coefficient of x is 0. Here, the coefficient of y is 0. So what this means here is this. Listen carefully. When you see y equals 2, this means that y is always equal to what? Y is always equal to 2. So if you think about this in terms of a t-table, x, y, we just said y is always equal to what? 2. That means my y column is always going to be what? 2. You have 2's down there. No matter what x is, no matter what x is. So if x is 0, what's y? 2. If x is 3, what's y? 2. If x is negative 4, what's y? 2. And so on. So if I plot those 3 points, you'll notice you get what kind of line? Plot those 3 points. Where do they lie? What kind of line is that? Horizontal. So 0, 2, 3, 2, negative 4, 2. See this horizontal line? So that's the line y equals 2. So whenever y is by itself, whenever the variable is y is the only variable you see, it's what kind of line? Horizontal. And it's easy to remember how to do this because this says that y is always going to equal what? 2. So that's what you're going to write in your mind. You're going to say, well, my y columns will be 2's, no matter what x is. So this is a horizontal line. What do you think x equal 2 will be then?
Vertical.
Vertical. And we'll do that. We'll finish this one next class period. Okay? All right. It's not difficult. It's fairly simple to do. So your worksheets look like this. I'll just quickly tell you what they look like. So now there are two. I'm going to post this video probably tomorrow, sometime tomorrow. But there are 2 videos on section 10.1. And 10.1 is just where you're plotting points, and then given a point, tell me where the coordinates are. Okay, so that's what this is. So guys, when it says for each point, indicate the coordinates. For example, let's say B was, I'm not saying it's correct. Let's say B was 5, 7. Make sure you put that in parentheses, right? Okay, but I don't think it's 5, 7. There's no back part. then this part is where, remember earlier, I gave you some values for x, you need to find the other coordinate, or given y, find the other coordinate. That's what this is. Okay? Now, don't confuse, this right here is just like the t-table. So, they're just saying if x is 4, what is what? When x is 4, what is it you got to find? Y. If x is negative 2, if y is negative 2, what is it got to find? X. And so if x is 4, how do you find y? No, well, one thing is to plug in for x, you plug in what? 4, and then solve for y. Get the variable y by itself. We did something like that earlier. Okay, so that's that. That's 10.1. 10.2 is where you start graphing lines. So that's this. Now listen carefully to what the part A says. Part A, I gave you a line, right? Now remember our discussion. We said that the solutions to this equation would be any point that's located where? On that line. So here's what the direction says. For each ordered pair listed, indicate whether the ordered pair is a solution or not a solution to this equation. So if negative 2, 4 lies on the line, then it's a what? If it doesn't lie on the line, then it's not a solution. You would check one of these off. Okay? And then given this equation here, state 2 ordered pairs that are on this graph. All of you can have different ordered pairs as long as it's on this graph, right? And then give me an ordered pair that's not on the graph. So there are an infinite number of possible answers here. And then remember we talked about linear versus not linear. So for each of these, you have to tell me whether it was what? Linear or not linear. So I gave you examples of all of those earlier. Okay? So you just check off if it's linear, check off if it's not linear. All right. And then part B. Now listen, make sure you label the points. So that means you got to tell me what those points are, right? So you got to find 3 ordered pairs, so it's easy to do a t-table. Do a t-table. In all of these, y is by itself. Here's the one with a fraction, so you want to use numbers that are divisible by what? 3. Okay? All right. So I'm going to give you those, so you can start working on those, and then we'll do more with this Thursday. It's not difficult, guys, but don't wait until Thursday to start working on this. Now, this is not due until a week from today. So for this here, okay, now, let me pass this out. Put your name here today's date, 3/26. Okay, all of you turn in your worksheets that are due today. Okay, make sure there are 2 there to do today. Make sure you turn them in. I'm going to put the keys up there. So here are the keys. Okay. Once you sign the roll, you can go. Don't forget to get the keys and the 4 worksheets, and the 4 worksheets will be a week from today. Yes.
I'm gonna be here Tuesday. I'm in the Army Reserve.
Okay.
I'm doing some field training.
All right, so email me your work. Yeah, email me your work. So take a picture of it and send it to me.